So let's get started. So a polynomial is basically a bunch of things that look like this thing I'm going to show you in just a second, all added together. So if you get something like, let's say 3x to the third, let me not make that a third just so there's not two 3's, 3x to the fourth. So this is a term, and a polynomial is composed of a bunch of terms that are added and subtracted together. So in your polynomial, you get, let's do this in a different color, you get your coefficient, and your variable. And then sometimes there'll be an exponent and other times there won't. There is, of course, there's your exponent. And the whole thing altogether is a term. Now, not every term, in fact, needs to have these things. In fact, any of them can be missing. So you don't necessarily need to have a coefficient. You don't necessarily need to have a variable, and the variable doesn't necessarily need to have an exponent. All you need is either a coefficient or a variable, really. So something like 5, that's a term, or just x. That's a term as well. That looks like an alpha. Just x. That's a term as well. X squared. That's a term. You could have 7x. That's a term. Your variable doesn't have to be x either. It could be anything else, right? You can use whatever letter you want. So all of these guys are terms, and a polynomial is just a bunch of terms that are either added or subtracted together. Right? So you don't have to have you don't have to have more than one term, but you can. And if you do, terms are separated by plus and minus signs. So polynomials have different names. Terms. Name. So for instance, a polynomial with one term is called a monomial. 2 terms is called a binomial. 3 is called a trinomial. And anything more than that, you might think 4 terms would be called a quadrinomial, right? Perfectly reasonable name. No. Nobody calls it quadrinomial, although I think everyone would know what you were talking about if you said that. But 4 plus, everyone just calls it a polynomial. And that's just kind of some general naming conventions. So if you hear a binomial or trinomial, we'll use these terms a lot. In fact, we'll use all these terms a lot, but binomials and trinomials are the ones that come up the most in what we're going to be doing here. The other thing I want to talk about is the degree of a polynomial. That actually turns out to be really important. So degree is the highest power in a polynomial, the highest power in a single term in a polynomial. Sort of. I'll show you what I mean. Highest power term, power, any term in a polynomial. So for instance, 5x to the fourth minus 18x to the third plus 7x to the seventh minus 3. So the degree of this polynomial is 7 because the highest power term has a 7th power. So degree 7. Now, this isn't exactly right because sometimes polynomials have more than one variable in them. Like you can do that. It's okay to have more than one variable in a polynomial. It doesn't come up all that much, but it is a thing that you can have. So for instance, 3a squared b plus 5a squared b to the squared minus 18a to the third b to the fifth. All right, sorry, this 3 doesn't look like a 3. It is supposed to be one, however. So here, when your polynomial has more than one variable in it, the degree is the sum of the exponents. So the degree of this first term here is 3. That's not the degree of the polynomial, just the degree of one term. So the degree here is 4, and then the degree here is 8. So that means that the polynomial is degree 8. Because the biggest term has a degree of 8. Now, the reason we care about degree is that when you learn more about polynomials, what you'll find is the way you classify them is by degree. All the third degree polynomials kind of look the same in a certain way, and all the fifth degree polynomials kind of look the same, and like fourth degree looks different than either of those. So the degree of a polynomial turns out to be really important and also really easy to find. You just pick the one with the biggest power in one particular term, and that's the degree of the polynomial. There is one other thing that you want to do with polynomials. So I'm going to go back to using first degree polynomials because that's mostly what we're going to be seeing. So if I see a polynomial like 7x minus 5 plus 3x squared, that is a totally valid polynomial, but not usually the way you write it. The way you want to write it is with the biggest degree term on the left, and then descending order. So this is called writing in descending order. 3x squared plus 7x minus 5. This is how you'd want to write this polynomial. And notice that I've got degree 2, then 1, 2 here, then 1, and then 0. When there's no polynomial, it's degree 0. Because you can think of 5 as like 5x to the 0 power, right? This bit is 1. So this term right here is like the 0th power term. And so you want to write it in this descending order. And the reason you'll do that is it's just convenience and ease of notation. So these two polynomials are the same. They're the same polynomial. If you graphed them, they would be the same. But it's usually written in this way for convenience. And so, and like in a really big polynomial, it's nice to write it like this, just so everything is orderly. So get used to writing it like this. Write all your polynomials like this. Nobody else writes it any other way, really. Let's see, did I hit everything I wanted to hit? I think so. Oh, there's one more point I wanted to make, which is one particular coefficient is called the leading coefficient, and it's the coefficient of the highest degree term. So the leading coefficient here is 3. There are other coefficients, but the leading coefficient actually tells you a lot about the polynomial, or it gives you some information about the polynomial that the other coefficients don't tell you. So make sure you know which one is the leading coefficient, because sometimes that's going to turn out to be relevant. Like when we're starting to factor, for instance, having a leading coefficient of 1 is significantly different than having a leading coefficient of anything else. It's just a lot easier to factor if it's 1. The other coefficients, not so much, like not nearly as important. So know what the leading coefficient there is. All right, the other thing I want to introduce is some notation, and I'm sneakily introducing function notation here. So the very common notation to use for polynomials is something like this. Let's say p of x equals 2x to the third minus 5x plus 1. All right, so the notation I want to introduce is this idea. You've probably seen this before at some point, but we're going to introduce it again. This notation turns out to be very both important and useful in math in general. So this is not something that like goes away after algebra. We're introducing this notation because this is how polynomials and other functions are written from here on, essentially. From here all the way on up, no matter how far you go in math, they're still writing functions like this. So it's really important to understand what this notation means. So firstly, this is not multiplication. This is not p times x. I know it's parentheses and you got two letters next to each other, but the way you read this is p of x. And what that means is, what we're saying here is that my polynomial here is called p and the variable is x. So for instance, if this is p of x, then p of t is the same polynomial, just with t's instead of x's. Right, and then p of z would be 2z to the third minus 5z plus 1. So the idea here is that this structure of polynomial is called p, and then whatever you put in here is your variable. And that works even if the thing in the parentheses is a number, right? So if p of x is 2x cubed minus 5x plus 1, p of t, same thing with t's, p of z, same thing with z's, then p of, let's say, 2 is going to be 2 times 2 to the third minus 5 times 2 plus 1. And you can actually get a number for that, right? That's a thing that we can actually find. So it's that 16 minus 10 plus 1 is 7, right? So I would say that p of 2 is equal to 7. And you can put in whatever number you want there. You just substitute it in for the variable. So like p of 1, which suddenly became capital P as it shouldn't be, is what you get when you put in 1, which is 2 minus 5 plus 1, or negative 2. P of 0 is 1. And you can identify P of 0 because all the terms that have any variables in them end up being 0 when you put 0 in for them. And the only one that doesn't is the constant term if it exists in that problem. So that's how you find, or that's how you evaluate polynomials. That's what the term is for putting a number into any function, but polynomials in specific here. It's called evaluating the polynomial at that number. So for us, p of 2 is 7, p of 1 is negative 2, p of 0 is 1. And the most common names for polynomials are p and q. I think because they p for polynomial and q because it's next to p in the alphabet. But you can use whatever letter you want, or whatever. Yeah, you can use, it doesn't have to be p. It could be n of x equals something, or j of x if you like. But again, I'll mostly use p and q because that's what everybody does. And this is how you evaluate polynomials. And I think that's the last thing I really wanted to say about this. Yeah, it is. Okay, so I'm going to go ahead and stop the video here, and I will see you guys in the next one.